only 1 over in the s block. Sodium's electron configuration is 3s1. Level 3, block S, 1 over.
1 over to the right?
1 over to the right. In other words, there is 1 electron in the s orbital. Magnesium is also in level 3, also in the s block, but it is 2 over, it is 3s2. It has filled its s orbital. Good, making sense is what I'm going for. It's just like Battleship. Aluminum is in period 3, 1, 2, 3. In the p block, 1 over. Aluminum's last electron is 3p1. Arsenic is in period 4, p block, 1, 2, 3 over. Arsenic's configuration is 4p3. See how this works? Now, this system works very, very well, except the D block.
Oh no.
But it's not as complicated as you might think. The D block is so high in energy, it has to be moved down. Let me explain. The S is very low in energy. It can only fit into the level 1. Sorry, more accurately, level 1 is so low in energy, it can only hold an S. Level 2 is so low in energy, it can hold an S and a P. Level 3 can hold an S, a P, and a D. Level 4 can hold an S, a P, a D, and an F. Okay? Yeah. So the reason that level 3, guys, the first D block is down here with the 4th period is because the D block orbital is so high in energy, it has to get pushed down. So, potassium is level 4, S block, 1 over, 4s1. What is calcium?
4s.
4s2. Scandium, however, is not 4d, it's 3d1. But why is it lined up with level 4? Because it's so high in energy, it has to get pushed down into the fourth level. Does that make sense? So level 4 holds the 3d, or period 4 holds the 3d.
So for all of it just starts at 3, 4, and then goes down?
Yep. Level 1, level 2, level 3, level 4, period 1, period 2, period 3, period 4. But where this is 4s1 and this is 4s2, scandium is 3d1, 3d2. Zinc is 3d10. Gallium, 4p1. Okay. And that's the only goofy thing you need to know.
What happens with the F block?
The F block has to get moved down 2. So the lowest energy F is the 4F, and it has to get moved down 2. The D gets moved down 1, the F gets moved down 2. So the F finds itself in the 6th period. This is 6s1, 6s2, 4f14, and then the D's. That's why it's kind of wedged in here. You see it wedged in here, and there's like a line, and then like put it in here. In reality, if you were to draw the periodic table, it would look like this. It would look like that.
You forgot helium.
I put helium over here. Sometimes helium is actually placed next to hydrogen. So we have our S, our F, our D, and our P. So that's what it would look like if you actually... But because we don't read, because our textbooks are not scrolls, they're books, we took the F and we put it in over here. And,
We should get scrolls.
yeah. Yeah. Roll it out. I'm going to need a longer desk. Okay. Okay, now electrons can be spin up or spin down. Now, spin kind of works like male and female. And I don't want to say what else it works like because I don't want to confuse you. But you can think of male or female, up or down, left or right. Now, orbitals act like rows in an airplane. If you're going to Reno And you're going to take a small airplane. This small airplane has 2 seats on the left, 2 seats on the right. You walk into the airplane, and you've all seen this commercial. You're the only one in the airplane, so you sit down. And then a big fat guy walks in, and he's the second person in the airplane. Where does he sit? Right next to you. You've seen this commercial. Well, that's not how electrons work. Electrons will fill all available rows first. And then if they come into the airplane, they're like, oh man, I have to sit next to somebody. Then they sit on their lap, right? No, they sit next to them. So electrons follow these rules. First, they're going to put 1 electron in every orbital. Just like 1 person in every row. And then they're going to sit next to somebody only if they have to. Make sense? And the last rule is they want to sit as close to the front of the plane as possible. That way they make sure they get their drink before all the Dr. Pepper is gone. Yeah, okay. You've all been there. So here's some rules. Electrons are going to be spin up or spin down. If an electron's by itself, it has to be spin up. That's Hund's rule. So electrons are going to fill all available orbitals with 1 electron, and it will be spin up. Just like when you walk into the airplane, you're going to fill all available seats, or all available rows, with 1 seat first. As they come in, you're like, okay, Hund's rule says I'm going to fill the orbitals with an up first, so you have a bunch of up electrons filling up the plane. And they fill to the front of the plane first. If they have to share an orbital, they have to do what's called spin pair. 1 up, 1 down. Okay. Just like you don't sit on the person's lap, you sit next to them. So you will spin pair. You'll be on the left, they'll be on the right. If an electron is already filled with an up, the next electron will be down. Okay, I have here 3 orbitals. What type of orbitals are these? They're p's. So I got 3 p orbitals, and watch very carefully how they will fill, using Hund's rule and then the Pauli exclusion principle. If you don't write Pauli exclusion principle, you just like Pauli's rule, I'll accept it. Watch how they do it. The first electron is going to fill up, then up, then up. The 4th electron will then fill down, down, down. They fill up, 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 and then down, down, down. They fill up available rows with 1 seat first. They only spin pair if they have to. Up, 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 down, down, down. Do you want to see it again? Okay. Spin up, 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 and then down, down, down. Okay, questions? Okay, so what do we have so far? We know that level 1 compared to level 2, which one has more energy? Level 2. Make sense? And we also know that a p orbital versus an s orbital, which has more energy? The p. But realize the overall energy is the combination of the 2. So a 1s versus a 2p, the 2p has more energy. Make sense? What if you looked at a 3s versus a 4s? Which one has more energy?
4s.
The 4s. What if you looked at a 3d versus a 4d? Which one has more energy? 4d. The weirdness comes in here. When you look at the combination of the 4s versus the 3d, it turns out that which one has lower energy? The 4s, exactly. You learned that electrons want to fill as soon as possible, and we know that the 4s, potassium and calcium, fill before the 3d for scandium. So the pretend this goes in the other direction. The 4s has lower in energy than the 3d. Does that idea make sense? Yeah. If that idea makes sense, I'm just going to blast right through the next slide. That's what it's talking about. Okay. So s orbitals are lower than f. Levels are lower than higher levels. So the combination of the orbital and the shell determines the energy of that electron. So 4s is lower in energy than the 3d, which is why the 4s fills before the 3d. And that's why the 3d happens after the 4s. If you're up front, you can see the whole electron configuration right here. How super cool is that? There it is. Like, man, I want to sit up front.
Wait, so 2p is greater than 3s?
Yep, 2p fills before the 3s. So, with the knowledge you now have, let's go through the periodic table. Everybody follow the green dot. Hydrogen is 1s1. Helium is 1s2. Lithium is 2s1. What is magnesium? What is beryllium? 2s2. Boron is 2p1. What's carbon? 2p2. 2p3, 2p4, 2p5. Neon is 2p6. Sodium is what? 3s1. Magnesium is 3s2. Aluminum is 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Potassium is 4s1. Calcium is 4s2. Scandium is 3d1. Well done. So scandium is 3d1, vanadium 3d3, copper 3d9, zinc 3d10, gallium is
4p1.
Excellent. Yeah, exactly right. 4p1. And krypton is 4p6. You guys get this, right?
Yes.
Okay, cool. So if you like diagrams, here's a diagram. You don't need to write it down, it's all over the internet. But basically, if you looked at level 1, level 2, level 3, level 4 bleeds into down here being lower energy than 3D. So if you like diagrams, there's a diagram. Moving on, because we only have 7 minutes left. Let's fill fluorine. Okay. Now fluorine all by itself, not an ion. Remember ions, they have more or less electrons? If the fluorine atom is chilling out by itself, since it's atomic number 9, it's also going to have 9 electrons. Now if it was an ion, it would have more or less. But in this case, it's just fluorine. Okay, so fluorine has 9 electrons. Let's watch how they fill. Up, down, up, down, up, 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 down, down. Nothing. Because fluorine is 2p5. 2p5. So there's nothing in there. There's like, but I want an electron. And that's why fluorine is super reactive, and we'll talk about that in November, that electron wants to go in there, so that makes fluorine very, very reactive. So this is fluorine's electron configuration. Write that down. Electron configuration. The electron configuration is with letters and numbers. The arrows give us the orbital diagram. Write that down. Because sometimes, even on tests, when I ask for the orbital diagram, people give me electron configuration. And when I ask for the electron configuration, people draw a bunch of arrows. No. Electron configuration is letters and numbers. Orbital notation, the orbital diagram, is with arrows.
I mean, one of the diagrams,
Mm-hmm.
so
You'd think, but every year there's 2 or 3 people who get them mixed up and they're like, why did I get this wrong? Where? Because you didn't pay attention to what I was asking for. So, orbital diagram is with the arrows, electron configuration with letters and numbers. Now this is red, 1s2, 2s2, 2p5. It is read like that. It is not read 1s squared, because it's not a square. It's just it's a number that says there's 2 electrons in the 1s, there's 2 electrons in the 2s, there's 5 electrons in the 2p. That's how it's read. That's what it means. Okay? Give me a thumbs up if you're with me so far. Some of you are, and some of you are giving me the stink eye. Okay. Okay. Next one. Copper. A normal atom of copper has 29 electrons. It's atomic number 29. Watch how it fills. Are you ready?
Nope.
Nope. Okay. Wait. How about now? Ready?
Yeah.
Okay. 1s is up, down. 2s is up, down. 2p is up, 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 down, down, down. 3s is up, down. 3p is up, 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 down, down, down. What's next? 4s. And it's going to be up, down, and then the 3d up, 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 down, 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 down. Okay. So copper ends up 3d10. So that's where we, or sorry, 3d9. So that's where we stop. Zinc would be 3d10. If we got rid of an electron, it would be 3d8. That would be nickel. Now, this is how the filling order is read. The filling electron configuration is read 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. We're going to learn Wednesday that there's an even faster way to write this. So we can just write the last thing.
Okay.
Yeah.
But for today and tomorrow, we're going to write the whole electron configuration just so we know what it is. Now, this is the filling order electron configuration. You will frequently find online people will, they'll group the orbitals together and they'll write it like this. They'll write the D in front of the 4s. You know, because you're smart, unless you're on your phone right now, you know that the 4s fills before the 3d, so you're not confused by this. This doesn't confuse you. Okay, you know this, right? Okay. I don't teach exceptions. If you want to play with exceptions, you're welcome to take Chemistry AP. But I'm not going to teach exceptions at Chemistry 1. And there is an exception. And the crazy exception is sometimes with nickel and copper, the 4s9 and, or sorry, copper and zinc, the 4s9, back up. The 3d9 and the 3d10 and the 4s1 and the 4s2 get mixed together. So sometimes you see copper written 3d10, 4s1. It's an exception. I'm not going to teach it. I'm just telling you so when you're online, because you're all diligent, you're all getting online like after school, I want to learn more chemistry. And you put it in YouTube, electron configurations, and you find the electron configuration for copper is written 4s1, 3d10. It's an exception. It happens. We're not going to teach it in this class. There will be no exceptions in this class.
And then you just travel through the recommended videos all the way until you find two videos.
Yeah. Or screen junkies and honest trailers of things. Okay. Any questions? So this is where we're going to stop today. Any questions? All right, cool.